In this video, we're going to look at interval notation, which is another way of representing the solution to an inequality. And keep in mind that when we solve equations, our solution was just one specific or two specific numbers. But when we solve an inequality, as we saw when we graph them, we're talking about a whole range of numbers. And an interval is another way that we can express that range of values. We have a couple different symbols that we use when we write interval notation. We have parentheses, brackets, and sometimes we also get to use infinity. So an interval will always have an endpoint and a beginning point. So if I, for example, have 2, 3, this means I start at 2 and I'm taking all the values that go up to 3. The parenthesis means that the endpoint is not included in the solution. So if I see a parenthesis, that means that I'm going to have an open circle if I graph, and it could be a less than or a greater than symbol. If I see a bracket, this means that the endpoint is included in my solution. So here we have the filled in circle, which means we have less than or equal to or greater than or equal to. For right now, we're going to be looking at intervals that extend forever in either the positive or the negative direction. So we're going to incorporate infinity in our interval to indicate that those numbers keep going. We keep adding values into that solution set. A little bit later on, when we look at compound inequalities, we'll look at intervals like this one, where we have two specific starting and end points. And I think it helps to look at the graph of these inequalities when we put the intervals together. So if I have x is less than or equal to 5, we can graph this on the number line. So we've got 0 in the middle, 5, and its opposite. I have that or equal to, so we know this is going to be a closed-in circle, and I want everything less than or equal to 5, so we're going to come off to the left. If it helps, you can show where negative infinity and positive infinity would be on your number line. Obviously, positive infinity is off to the right with the positive values. You don't need to write the plus sign there. And negative infinity is off to the left with the negative values. I look and I see which way my graph is facing. My graph is pointing down towards negative infinity because my values keep getting smaller and smaller and smaller. So I'm taking negative infinity in my interval, and I want everything up to 5. Now we go back to our inequality. Because we have that or equal to and that closed circle, this means that 5 is included in our solution. So I'm going to put a bracket on there. The bracket kind of squares up and latches onto the solution, keeping it in the solution set. Now, infinity itself isn't really a number. It's more a concept that we keep going further and further in that direction. So I can't put a bracket to latch onto that specific value. Instead, we put a parenthesis. Infinity and positive or negative infinity always get parentheses around them. We will never put a bracket on there. So the interval for this specific inequality is negative infinity to positive 5. If we look at our second one, we have y is greater than negative 2. So if we visualize this on the number line, we've got negative 2, we've got 0, we've got positive 2. Because it's strictly greater than, we have an open circle. We want all the values larger, so 0 and 2 are larger than negative 2, so we come off this way. We can put negative infinity and positive infinity on there just to kind of help us see where we're at. So we have negative infinity on the left-hand side and positive infinity on the right. Now we need to think about my interval. If we look, we see that our graph is headed off in the positive direction, meaning we keep adding those values to our solution set. So we're going to have positive infinity. But we start at negative 2. We always read our intervals left to right, start to finish. I should be able to take my interval, place it on the number line, and have those values be in the correct option, in the correct space. So if I take this and I write it, I have negative 2, positive infinity, infinity's on the right, and negative 2 is on the left. It wouldn't make sense to have infinity here and negative 2, because positive infinity is not smaller than negative 2. This is a positive value, these are negatives, so this does not work. Then we look at our open circle. We have strictly greater than, so this is a parenthesis, and infinity always has a parenthesis attached to it. This works the same even if our inequality is written kind of backwards. We can rewrite it as a is greater than or equal to 3. So we can think about this one. If you want to try it without the graph, we know that we're taking all the values that are equal to 3 and higher. So we start with 3 and we're going to positive infinity. Because we have the greater than or equal to, we put the bracket, and then infinity always gets a parenthesis. If we start with y is less than 0, this means that we want all the values that are smaller than 0. As soon as my variable is less than a number, I start with negative infinity, and we go all the way up to 0. Because it's strictly less than 0, we have a parenthesis, and then another parenthesis on negative infinity. Another question that you might see is where you're given an interval and you're asked to reproduce or match the graph. So if we have the interval 4 to infinity, if I start with my number line, I have 0, we'll put 4 and its opposite. I know that I'm going to have a circle on 4. We see a parenthesis next to 4, so it's an open circle. And our next value is infinity, so we're going off to infinity and beyond, if you're a fan of Buzz Lightyear. Likewise, if we have an interval negative infinity to negative 2 with a bracket, we can construct a graph from this as well. So we have 0, we have negative 2, we have positive 2. I can look, I see I'm going to have a circle at negative 2. I have a bracket there, so it's going to be closed. And we want everything less than that down to negative infinity. So we come this way. And we can write inequalities to match these. So this would be x is greater than 4. And here we would have x is less than or equal to negative 2.